Inverse functions. Celsius inputs to Fahrenheit outputs. Let C be the Celsius temperature and F be the Fahrenheit temperature. The function g converts Celsius temperatures to Fahrenheit temperatures. If my input is a Celsius temperature of 0, then the output is a Fahrenheit temperature of 32. Input 20 degrees Celsius, output 68 degrees Fahrenheit. Input 40 degrees Celsius, output 104 degrees Fahrenheit. Inverse functions. For each Fahrenheit temperature, there is exactly one Celsius temperature, so the new relation is also a function. This function is the inverse of g and is written as g to the negative 1 and is read as g inverse. The inverse function would start with Fahrenheit as the input and give the Celsius temperature as the output. So a temperature of 32 degrees Fahrenheit will give us an output of 0 degrees Celsius. 68 degrees Fahrenheit would give us an output of 20 degrees Celsius. 104 degrees Fahrenheit would give us an output of 40 degrees Celsius. G inverse sends the outputs of G to the inputs of G. G sends the input 0 to the output 32, and G inverse sends 32 to 0. G of 0 equals 32, and G inverse of 32 equals 0. These two statements are equivalent, which means that one statement applies the other and vice versa. G inverse undoes G. G sends 0 to 32, and G inverse undoes this action by sending 32 back to 0. The inverse of a function f is a relation that sends b to a if f of a equals b. The inverse of a function is not necessarily a function. If the inverse of a function f is also a function, then f is invertible, and use f inverse as the name for the inverse of f. We say that f inverse is the inverse function of f. Property of an inverse function. For an invertible function f, the following statements are equivalent. F of a equals b, and f inverse of b equals a. If f sends a to b, then f inverse sends b to a. If f inverse sends b to a, then f sends a to b. In this example, some values of an invertible function f are shown in the table. Find the following. In our table, if x is 0, f of x is 1. If x is 1, f of x is 3. If x is 2, f of x is 9. If x is 3, f of x is 27. If x is 4, f of x is 81. Part A, we want to find f of 3. Going to our table, we find 3 under x. If 3 is the input, then 27 is the output. So f of 3 equals 27. For part B, the inverse function of 9. Since we're looking for the inverse, we want to find 9 under f of x in our table. If our input is 9, then the output is 2 under x. So f inverse of 9 equals 2. F and f inverse are inverses of each other. If f is an invertible function, then f inverse is invertible. F and f inverse are inverses of each other. This example, some values of an invertible function f are shown in the table. Find the following. For our table, x is 2, then f of x is 3. When x is 3, f of x is 6. When x is 4, f of x is 12. When x is 5, f of x is 24. When x is 6, f of x is 48. Part A, we want to find f of 3. We locate 3 under x. If 3 is the input, then our output is 6. So f of 3 equals 6. Part B, f inverse of 3. This time we want to locate 3 under the f of x column. If our input is 3, then our output is 2. So the inverse function of 3 equals 2. In this example, some values of an invertible function f are shown in the table. Create a table of values of f inverse. Using the same table from the previous example, we want to create a table showing our inverse function. For that, our input becomes the output of f of x. So everything under the f of x column now becomes my x, and everything under the x column becomes my output. So if I have an input of 3, I have an output of 2. So all my values under f of x now become my x. So under x, I have 3, 6, 12, 24, and 48. For my f inverse of x, I write my values for x. So I have 2, 3, 4, 5, and 6. When writing the inverse of a function, we reverse the values of x and f of x. Graphing inverse functions. Reflection property of inverse functions. For an invertible function f, the graph of f inverse is the reflection of the graph f across the line y equals x. Graphing an inverse function. For an invertible function f, we sketch the graph of f inverse by the following steps. 1. Sketch the graph of f. 2. Choose several points that lie on the graph of f. 3. For each point AB chosen in step 2, plot the point BA. 4. Sketch the curve that contains the points plotted in step 3. In this example, graph by hand the equations of f, f inverse, and y equals x on the same set of axes. Our function f of x equals 1/3 x minus 1. Filling in our xy table, if we let x equal 6, 3, 0, -3, and -6, this will give us enough points to graph our function. Finding f of 6, that equals 1/3 times 6 minus 1. 1/3 times 6 equals 2. 2 minus 1 equals 1. So my first order pair is 6, 1. I'm also going to find f of -6. That equals 1/3 times -6 minus 1. 1/3 times -6 is -2. So this equals -2 minus 1, which equals -3. So I have the order pair -6, -3. For f of 3, that equals 1/3 times 3 minus 1. 1/3 times 3 is 1. 1 minus 1 is 0. Now finding f of -3, 1/3 times -3 minus 1 equals -1 minus 1, which equals -2. So I have the point -3, -2. Now finding f of 0, that equals 1/3 times 0 minus 1. 1/3 times 0 is 0, and 0 minus 1 is -1. So I have the ordered pair 0, -1. Graphing my function, I have the order pair -6, -3, -3, -2, 0, -1, 3, 0, and 6, 1. To find my inverse function, what I want to do is take my values from f of x and put those in the x position, take my values from x and put them in the f inverse of x position. So my first order pair becomes 1, 6, then 0, 3, -1, 0, -2, -3, and -3, -6. Then graphing my function f of x, my function f inverse of x, and y equals x all on the same graph. I have for my inverse function 1, 6, 0, 3, -1, 0, -2, -3, and -3, -6. This causes a reflection over the y equals x line. So another way that we could graph our function is by plotting its reflection using y equals x. Finding an equation of the inverse of a model. Let f be an inverse function. To find the inverse of f, where y equals f of x, number 1, replace f of x with y. Number 2, switch the positions of x and y. Number 3, solve for y. Number 4, replace y with the inverse function of x. If each output of a function originates from exactly one input, we say that the function is one-to-one. A one-to-one function is invertible. In this example, find the inverse of the given function. Use a graphing calculator to verify your work by graphing f inverse of f and y equals x on the same set of axes. F of x equals 3x minus 8. Our first step is to replace f of x with y. So I have y equals 3x minus 8. Switching the position of x and y, my equation becomes x equals 3y minus 8. Solving the equation for y, I want to add 8 to both sides, which is x plus 8 equals 3y. Now, divide both sides by 3. The result is x plus 8 divided by 3 equals y. This is my inverse function. So f negative 1 of x, or the inverse function of x, equals x plus 8 divided by 3. Using my calculator to graph the functions, go to y equals, then I want to type in my first function, 3x minus 8, arrow down, parenthesis, x plus 8, close parenthesis, divided by 3, arrow down, y equals x, so I type x. Graph. My blue line is my function f of x. My green line is my function inverse f of x. And my red line is y equals x. And our two functions do reflect each other over the red line. So our answer is correct. In this example, find the inverse of the given function. Use a graphing calculator to verify your work by graphing f, the inverse of f, and y equals x on the same set of axes. Our function f of x equals 6x minus 2 divided by 5. Replacing my f of x with y, my result is y equals 6x minus 2 divided by 5. Next, change the position of x and y. So x equals 6y minus 2 divided by 5. Solving for y, I want to multiply both sides by 5. That gives me 5x equals 6y minus 2. Adding 2 to both sides, my result is 5x plus 2 equals 6y. Then I want to divide both sides by 6. So I have 5x plus 2 all over 6 equals y. Now I'm ready to change my y to my notation for the inverse function. F negative 1 of x equals 5x plus 2 all over 6. Using my calculator to graph the function, press y equals, then clear to get rid of the equation, and I type parenthesis 6x minus 2 close parenthesis divided by 5, arrow down, so I can adjust this function by arrowing over my x. I want to type a number in front of x, so I press second delete, which is my insert. The x changes from the x to a line at the bottom. I type in 5, and it inserts 5 in front of x. Then I arrow over, replace the 8 with 2, arrow over, and replace the 3 with 6. And I still have my y equals x. So I'm ready to graph. The blue line is my function f of x, the green line is my inverse function of x, and the red line is y equals x. Since the lines are really close together, I want to get a closer look. So go to Window, change my x min to -5, my x max to 5, my y min to -5, and my y max to 5. Graph. Now it's a little easier to see my three functions, and we can see that my green line is a reflection of my blue line over my y equals x red line. Inverse functions. I can find the inverse of a function by switching the inputs and outputs of my function. I label my inverse function with f negative 1 parentheses x. When I'm graphing inverse functions, the inverse of a function is a reflection of the function over the line y equals x. Finding an equation of the inverse of a model, I take my function f of x, change my f of x to a y, switch my position for x and y, solve the result for y, then I have my inverse function, and I change my y to f negative 1 of x, and I can always graph to make sure I do have the inverse of my function.